Hey there, I'm going to talk to you today about some different ways of averaging data and some different calculations that are involved with that. We're going to talk about range, mean, median, and mode. So let's get rolling here. First of all, I want to talk to you guys about range. Range is the difference between the lowest and the highest value. So if we've got this set of data, if we got this set of numbers for our data set, 4, 7, 8, 6, 5, the range would be the difference between the highest and lowest value, which would be, the range is the highest minus the lowest value, and your highest value is the 8 and your lowest value is the 4, so the difference between the two of them is 4. Now, range is not a way of range is not an average. It's not a way of averaging data, but what range is, more importantly, what it does is it tells you the precision of the data. The smaller the range, the more precise that data is. So you want to have a nice small range. That means all your data points are very close to each other. If you have a huge range, then it's not as precise. So range is telling you something about precision. The next thing I want to talk to you guys about is mode. Mode is the value that appears most often in a data set. If a number does not appear more than once, then you have no mode. So it has to appear more than once. What would be the mode of this data set? We've got 8, 5, 6, 5, 7, 9. Well, to figure out the mode, you just find out which number appears most often. And you can see here the 5 is what appears most often. And like I said, you may not have a mode if something doesn't appear more often than once. But let's take a look at this data set. We've got 8, 5, 6, 5, 7, 9, 7. What would the mode of this be? Well, we've got our 5s again, but we also have 2 7s. So yes, you can have more than one mode. And when you have more than one mode, it's called a binomial list. That's when you have 2 modes. So this is an example of a binomial list because it's got 2 modes. How about this one here? What is the mode of this data set? Again, we've got the 8, 5, 6, 5, so we got our 2 5s, 7, 9, 7, we got our 2 7s, but now we've got another 8 here, so we've got 2 8s. So we have 3 of them that appear equal amounts. We have 2 8s, 2 5s, and 2 7s. So we have 3 modes in this one, and this would be called a trinomial list. That's what 3 modes. So things that you see commonly, or the common values, those are modes. The mean is the sum of all values divided by the number of values. You most often think of that as your average. You take up all the values and then you average them. So let's take a look here. Determine the mean for this data set. We've got 8, 5, 6, 5, 7, 9. What would the mean of that be? Well, to do this, we sum up all the values, so that we sum up the 8, the 5, the 6, the 5, the 7, the 9. We sum up all of these, and then we take that answer and we divide it by 6. That would be 40 divided by 6. And when you put this in your calculator, you're going to get 6.6, and it's going to repeat infinitely. So at some point, you have to round off, because after this 6 is 6, 6, 6, 6, 6, it just keeps going. So at some point, you have to round off, and the number that was after this 6 was a 6, and if it's 5 or greater, we round up. That's why I put a 7 here. So at some point we have to round up. In science, we don't put that little bar of an infinite value sign. It doesn't go on forever. And I'll talk more about how many digits you should write in your answers in a later video. The next is the median. The median is the middle number in a list of numbers when you order them from highest to lowest, or lowest to highest, or lowest to highest, or highest to lowest. It's a sequence. When you have a sequence, the middle number is the median. So let's take a look at this data set here. We've got 9, 4, 5, 8, 11, 13, and 6. Now you cannot figure out the median very easily unless you put these in order. So what you have to do is rewrite this going from the smallest to the largest. And I'm going to give you a tip right now. When you have a large data set, what I would do is, so 4 was our smallest one. You put when you write your 4, cross out that 1. And then you got your 5, cross out the 5. Then you saw your 6, cross out the 6. So you make sure that you're using every single number, because it's real easy when you get a lot of numbers, and you're going to have that in lab, to forget a number. The other thing is, when you're done writing this list, count your numbers. You got 1, 2, 3, 4, 5, 6, 7. Make sure in your ordered sequence you also have the same amount. So 1, 2, 3, 4, 5, 6, 7. So double check, and like I said, cross it out as you go along. So anyways, what would be the median for this data set? Well, we've got 7 numbers, so that would mean we'd have 3 on each side. So I've got 3 on each side. That gives us 6, and the seventh number, or the fourth number, I should say, because you got 3 on each side, that's your middle number here. So the median for this data set would be 8. That's the middle number once it's in order. Let's take a look at this. This is a great example of an odd number of numbers. So we've got 7 numbers here, so it's the middle number. Let's take another look at an odd set. We've got 8, 3, 5. Again, the 3 is not your median because we have to put this in order, so numerical order. So 3, 5, 8. The center one, 5, is your median. But what happens when you have an even number of values? When you have an even number of values, you average the 2 middle values. So let's take a look at this set here. We've got 7, 8, 3, 5. Again, let's put this in numerical order. 3, 5, 7, 8. We have 2 middle numbers, the 5 and the 7. So we're going to take the average of the 2 middle numbers. So the average between 5 and 7 would be 6. And how you would do that, if it's not an easy thing like this, you just add up the 2 and divide it by 2. So 5 plus 7 is 12, divided by 2 is 6. But something like that you should be able to do in your head, right? I hope so. All right. Next one is, how do we know which average to use? Do we use the mode, mean, or median? Again, mode is the one that shows up the most often. So if you just have a large amount of numbers that's showing up quite often, you're going to probably pick the mode. But let's focus more on the mean and the median right here. Let's take a look at this example. A company employs 5 people. 4 workers each earn $40,000 a year, while the manager earns $100,000 a year. So let's take this information here and determine the mean. And so to figure out the mean, we would have to add up all of the salaries. So we've got 4 workers, 1, 2, 3, 4, earning $40,000. And we have 1 worker, the manager, that makes $100,000. So we have 1, 2, 3, 4, 5 values. So I'm going to take this sum, divide it by 5, and I come up with $52,000. So the mean of this payroll is $52,000 per year. If we take a look at the median again is the middle number. I'm going to take these numbers and I'm going to put them in order. And then the middle number is the median. So the median is $40,000 per year, and the mean is $52,000 a year. So here's our values again. I just put it up here. So what are we going to do? Which one is the best? Would you use the mean or would you use the median when determining the estimated salary of the employees? And a lot of people might think, well, you use the mean for everything because you add up all the numbers. All those numbers count, and you add them up, and that's how you get your value. But if you really think about it, the mean salary of $52,000 is not even close to the estimated salary of any of the employees. $52,000 is as much, that's $12,000 more than any of the workers get, and it's significantly less than the manager gets. So it's not a very good estimate of what anybody makes here. In other words, if you were to work here, odds are, if you were to work here, you would probably be earning $40,000 a year, the median. So in a situation like this, the median is a better representation of how much a worker would get at this company. An average worker is not getting $52,000 a year. The average worker is getting $40,000 a year. So sometimes the median is better to use than the mean. So one weakness of the mean is that it gets affected by extreme values. This manager's salary is way off the scale from the other workers, and it affects the mean quite a bit. So extreme values affect the mean quite a bit. If there are extreme values, median gives a better estimation of the data set. So in sum between the two, the mean is the sum of all the values divided by the number of values, where the median is arranged. You put them in order and you find the middle value. Values of data, every value is considered for the calculation. So mean is a good thing if you don't have those extremes, because every single value in your data set is relevant. However, with the median, not every value is considered. So it doesn't matter what those numbers are at the extremes. All that matters is that middle number. So everything is not considered in median, where everything is considered with the mean. So what I was trying to say before is with your extreme points. Extreme points greatly affects the mean. So greatly affected by extreme points is the mean. So you get an extreme point like that example with the manager's salary, it really changes the mean's value. However, extreme points don't affect the value of your median, because again, you're just looking at the middle. It doesn't really matter what those outliers are. Let's take a look at this graphically. If you have the values separated around, so this is frequency, so this is also our mode, this is the most frequent number. So if our mean and median are equal, and in this case here, you would also have our mode are equal, so these values here are most common, and then as we go this way, they're less and less common, and as we go this way, they're less and less common. This is something called a symmetric data set. It's symmetric on both sides. They're evenly spread out from the center, as opposed to a skewed data set. In a skewed data set, you have an extreme. So again, if you kind of take a look at symmetrical, if you were to have symmetrical, this would come up here and this should drop down here. But you've got few, because frequency down here, you have few values over here that's shifting everything to the right. And so in this case here, the median is less than the mean. So the median is right here. That's the middle point of the values. And the mean is way over here. So in a skewed data set, the median would be a better representation. In this situation here, again, if it was symmetric, we'd have our value like this, but we have some few skewed values way over here on the low end. In this case here, the mean is less than the median. So here's our mean, the calculated average, the sum divided by the total, and here's our median, which would be the center point. So again, the median would be a better representation of this data than the mean. If it's skewed on the high end, it's skewed to the right, you would know this because the median is less than the mean. If your median value is less than the mean, it's skewed to the right. Skewed to the right, excuse me. And if your mean is less than your median, so here's the mean, what you calculated, is less than the median, the center point, then it's skewed to the left. Here's some practice problems. If you go to mrask.com, you can print this out and you can just write it. I have a PDF there you can print and download. But otherwise, just pause the video here and see if you can do some practice, see how much you understand here. By taking these data sets, determine the range, mean, median, and mode for the following data sets. So I've got some numbers here. And I just put a space here so your eyes don't wander. There's 5 numbers here and 5 numbers here. 5 numbers, 5 numbers, 5 numbers. So the space is just so that you can kind of see and break it up, because the numbers start to get a little overwhelming when you have a whole bunch of numbers here. And the same thing with this here. And then after you figure out the range, mean, median, and mode, to really test if you understand what I was talking about here, identify which sets have symmetric or skewed data, which sets are better represented by the mean or median, and which lists are binomial or trinomial. So see if you can figure this stuff out with this data set. If you can, then I would say you have a good understanding of what we're doing here. If you have any questions, please drop me a note, post a message, and I will be happy to help you out. Good luck. Thank you.